Hey everyone, in this video, I'll walk you through my CMP assignment, which is building neural networks on MNIST dataset. So, first, we import everything we need, like NumPy, Matplotlib, and Seaborn. And we need Keras for building and training models. And for evaluation, we need scikit-learn. We also need to import ROC curves and precision recall matrices, and we import layers and models and callbacks from TensorFlow.keras. Then comes the loading part. We load MNIST directly from keras.datasets. That gives us about 60,000 training and 10,000 test images, each 28 by 28 pixels, grayscale with pixel values from 0 to 255. And then we visualize a grid of 20 sample digits just to sanity check how the data looks. Here it is. Then we come to class distribution. This cell plots the distribution of digits in both the training and test data sets. We want to confirm the classes are roughly balanced, and they are, which means we don't need to worry about imbalance in this problem. Then we come to pre-processing. Now we pre-process by normalizing pixel values from 0 to 1 by dividing by 255. Then we create two versions of data: a flattened version with shape 784 for dense model, and reshaped version with channel dimension added for the CNNs. And labels get one hot encoded, and we carve out 6,000 samples from training as validation set. So uh, top is original, and the bottom one is augmented. So yeah, here we augment the data by, you can see we augment by shifting and zooming and shearing. So these are all the data augmentation techniques. Now let's come to model architecture, which is the most important part. Here we define three architectures. Model 1, which is a simple dense network, two hidden layers with 256 and 128 neurons, ReLU activations, and dropout for regularization. It takes the flattened 784 dimension input. Now model 2 is standard CNN with 32 and 64 filters, batch normalization, max pooling, and then dense layer on top. And lastly, model 3, which is advanced CNN, it adds L2 regularization, uses global average pooling instead of flattening, and gets trained with the augmented data. All three compile with Adam optimizer and categorical cross entropy. Now let's come to like so these are the parameters of models. Now let us come to training the model. We train all the models for 5 epochs, and batch size would be 128. Here you can see 5 epochs for each model, and here is the training history. You can clearly see the CNNs converge faster. You can see CNN, which is the green one, it converges way faster compared to the other ones. So it's a good model basically. And then we do a comprehensive evaluation. The evaluation function runs predictions on test set and computes everything: accuracy, loss per class, precision, recall, and F1. It prints a full scikit-learn classification report, and the advanced CNN hits around 99.4% accuracy, the standard CNN about 99.2, and dense network about 97 to 98%, which is good. And for evaluation, for the more evaluation, we make confusion matrices. um, like the diagonal should be dark, that means correct predictions. The few off diagonal entries show where the model confuses digits, like here. Common confusions like things like 4 versus 9 and 3 versus 5, which are even sometimes not possible for humans to recognize. And now we do per class matrices, and you can see cn is consistently the highest across the board. CNN means the green one. And then finally we come to ROC curve. It plots per digit for the best model. Each curve shows the true positive rate versus false positive rate, and with AUC values very close to 1, this confirms the model is really good. And yeah, and then we make precision recall curves. This is also a metric. Then we do model comparison. Like you can see the accuracy of CNN is better than dense. And the last thing we do is misclassification analysis. We look at what the best model gets wrong. We display 20 misclassified samples with true labels. So if you look at this closely, these are pretty hard, like even for humans. Some are messy that even a human can't figure it out. So I think the model is really good. And then we do grad cam visualization. Like this shows the region of images where CNN focuses on making the prediction. Like it's an insight to the model. So model is genuinely trying to learn something meaningful, like some features, not just memorizing what's the thing. Like you can see the model is learning pattern of zero, like it forms a dark spot in between. So yeah, that's our video.